that can automatically take trades on your behalf following a specific strategy. And the code I will be using is available for download from the link in the description below, so you can just follow the video for now and then download the file to use it as you like. And what I will show you here in this video can work for any strategy that can fit in a Python function. And this might be the best way to test any strategy on a live market instead of simply backtesting on past data. If you want to test it on future data or on live data, you can use whatever is presented in this video. So this is our Jupyter Notebook file. I'm going to download some data, some historical data first. We're not going to use this data for the live trading. It's mainly to test if our function or our signals are working. So we need to test our signal functions first to see if they are working. And I'm downloading from the Y-Finance module, the Euro US dollar exchange data between two dates, the starting and the end date. And I'm using the 15 minutes time frame here. Something we should be aware of regarding this particular cell here is that when we are trying to download data for low time frames, like the 15 minutes interval, for example, Y-Finance only allows the last 60 days of data. So we can't download more than 60 days at once. And these have to be the last 60 days from the current date. So in case you download the file and it's not working, just pay attention to these particular dates here, the start and the end date. Now we can test what we have just downloaded. I'm going to comment these two lines. We can see that this row here was downloaded. Now if I remove this -1, so we have the whole data frame and it's around 3,973 rows. As you can see, we have the date time, we have the open, high, low, close, and the adjusted close prices. The volumes are not provided for this data frame, but we're not going to use these for this video. The second part is to define your signal generator. So it's a function basically where you give your data frame, current data frame, because when we are streaming data, live data for our trading bot, we're going to acquire a data frame, and then we can feed the data frame to this particular function, and the function is going to return a signal. Is it a buy signal, a selling signal, or no signal, no clear pattern? In this example, I'm using something very simple. We're detecting only the engulfing patterns, the candles engulfing patterns. Now, this is not a full strategy, but it serves for the purpose of this video. Please, if you want to build a strategy, this is where you can insert your signal generator strategy within this function. So for example, this function takes a data frame and we're going to read the open price, the closing price of the current candle or the last candle of the data frame. This is why I'm using the index -1, and the opening price and closing price of the previous candle, the one that comes before the last candle. And this is how I'm going to test if the last couple of candles of my current data frame have the engulfing pattern. And if it's happening as a bearish engulfing pattern, these are the conditions to be used. We are returning 1. The function is going to return 1 as a signal, which is a selling signal. And if it's a bullish engulfing pattern, we're going to return 2, which is a buying signal. If we don't have any of these two patterns, we're going to return 0. So how do I know that this function is working? I'm going to test it in these couple of lines here. And this is where we're going to use the historical data just to test this function. I'm going to check, first of all, I'm going to create a list called signal, and I'm going to append 0 for the first element of this list. So we don't have a signal at first, but then I'm going to loop over all the data frame, all the rows of the data frame. And for each row, I'm going to check if we have an engulfing candle using the function that we have just created, the signal generator. So I'm going to feed the data frame, but not all the data frame, like the last 2 rows of the data frame, just to make sure that we are using the correct set of data. And I'm going to append whatever the signal generator function returns into my signal list. Then I will add this as a new column into my testing data frame, and I can print the whole data frame, and I can see that I have an additional column here. Now, all what I can see for the moment are 0 signals, but we can do a value counts, and we have 3,617 0, meaning no signals. Buying signals, we have 180, and selling signals, we have 176 bearish engulfing candles in the data sets that we presented. Okay, so again, this is simply a very simple example. This is not a real strategy. It's just to make sure that our bot is working correctly. So now we can use it. It's working. I'm going to connect to the market and execute trades. So first of all, before you write a strategy and try to automate it, you have to make sure that your broker supports an API connection and they have sufficient documentation to allow you to connect to their platform through Python and execute trades. Oanda is not the only one. We have Binance and other brokers. This is not an advertisement for Oanda. They didn't sponsor this video. It simply happened that I've been using this broker and I have an account there and it's working fine for what I wanted to do. So feel free to simply jump to different brokers and just read their documentation. Here I'm going to show you how I do it using Oanda, how I connect to their platform. And for different brokers, it might be a very similar approach as well. So I'm going to import all the libraries and the modules I'm going to use. I don't think we are going to be using the candle collector. We need to create an account at the broker we're going to be using. And you don't have to create a real account. Oanda offers a demo account, which is what I did for this video. So when you create your account, you can have an account ID on their platform, and you have an API tab where you can create an access token. It's just one button you click to create an access token. You simply copy it and paste it. So in my case, I put these into a config file, and this is why from my config file, I'm importing the access token and the account ID just to keep these on the side. But if you don't want to do this, you don't want to include this line and put these into a config file, you can simply put your access token as a variable here. You can also put this as a global variable, meaning you can put it outside of the function. It works better. So this way it is visible in all the program later on. So now we can define the first function, which is the get candles, because we need to acquire the candles from our broker's platform. So get candles is only a function that will go and grab the candles live now, the current candles on the market, and we will have the open, high, low, and closing price for each candle for the moment. So we're going to get the last n candles, for example, going to grab the last 3 candles of the market. And the way to do this is that I'm going to use the candle client of Oanda. I'm going to provide the access token, and the real value is equal to false because this is not a real account. It's a practice account for the moment. And then I'm going to define a collector variable, which is the client.getCollector. And the pair is going to be Euro US dollars, and the granularity is going to be M15. So you can find the list of these options on Oanda's documentation if you need to change these to daily or 4 hours or the hourly bar charts, the time frames. So for the moment, we're using the 15 minutes time frame, and this is what we're going to use. And candles are going to be equal to the collector.grab the last n candles. N is a parameter that we're going to provide for the get candles function. So all of this is provided within the function, and then the function returns the candles. So the candles are going to contain information about the opening price, the closing price, the high and the low prices for each candle. And to make sure that this is working, I'm going to define candles outside here and call the function get candles to get the last 3 candles. And for each candle within the candles that I just pulled from the market, I'm going to print the opening price and to check if the opening price is above 1. And the reason I'm doing this is that you have to be careful what type is this variable. Candle.bid price, you can also provide the ask price. .open is a price type that is proper to Oanda's platform, but here we need to transform it into a string, then to cast it into a float to be able to compare it with a numerical value, which is 1 in this case. So I'm going to print these, and we can see that true, meaning the last 3 candles opening prices were above 1 with the Euro US dollar prices. So great. Now we have a function called get candles. When we call this function, it's going to provide us with the last 3 or n candles on the market. So we can use it later on to call the candles, analyze the candles, and check if we will be passing any buying or selling positions on the market. So now I'm going to define another function called trading job, because it's going to contain all my trading execution. So first of all, inside of the function, we're going to call the get candles function. We're going to get the last 3 candles on the market. We don't need any more candles. The current candle, meaning the last candle, is not closed yet. Remember that the last candle is still moving, so the closing price is fluctuating. This is why we need 3 candles. I'm going to make my test if I have an engulfing pattern on the previous couple of candles. So those that already closed, and we know the opening and closing prices. We're going to call these 3 candles. We're going to store the information in candles variable, and then I'm going to create a df stream and as data frame with the open, close, high, low prices. And I'm going to fill the information of these candles. For each candle within candles, I'm going to fill the information into the data frame. And then we have to cast the types of the columns again into float, otherwise it wouldn't work. And then I'm calling the signal function, and I'm providing the data frame that I've just downloaded live from the market. So we're getting the candles, putting these into a data frame, and feeding this data frame into our signal generator function that we have just explained above. And the signal generator function is going to read the last 2 closed candles, check if we have an engulfing pattern, buying or selling engulfing patterns, return this as a signal, and we're going to use this signal in case we want to buy or sell. But before that, we need to define our take profit and stop loss. And this is done in this part of the code. So we have the previous candles range. I'm going to use something very simple here. I'm going to look to the previous candles open minus close prices. So this is the range of the candle. And I'm going to use this as a stop loss distance for the moment from the current buying or selling price. Then the take profit is going to be twice, because the stop loss take profit ratio, or the take profit stop loss ratio, is going to be equal to 2. So it's multiplied by this ratio. So that distance is multiplied by 2 for the moment to set our take profit prices. So we have different prices, whether it's a buying position or a selling position. So for example, we have the stop loss in the buying position is equal to the current opening price of the current candle minus whatever we defined as a stop loss distance. And in the case of selling position, the stop loss is equal to this opening price plus to whatever we defined as a stop loss distance. So anyway, it's not very important as long as you know what you are doing and how you would like to set your stop loss and take profit values. So you can set these right here, and then I'm printing these whenever I'm calling the function just to make sure that the values are reasonable. And then we have to define a client function with the API and provide the access token. If the signal is equal to 1, then we're going to pass a selling position. And the way we're going to do this is by checking the market order request function. We're going to provide the instrument, which is Euro US dollar. And since it's a sell, I'm going to sell a negative number of units. So this is why we have minus 1,000 here. It's 1,000 plus 1,000 in case we are buying. The take profit is equal to whatever the take profit distance is, and this syntax to provide it to this function, and the stop loss is equal to whatever the stop loss is in this case, and this is the syntax we're going to use. For buying positions, it's the same, only we provide positive units in this case because we are buying. Then we define a new function. I called it R here, orders.orders create the account ID and the data equal to mo.data. So this is my market order data. I'm going to pass it as a parameter for this function here. At the end, I'm going to call the client request function. I'm going to print RV just to make sure that the order was passed, because every time we have an executed order, we're going to have something on the screen. So it's safer this way. We can see at least that an order is executed. So far we have our signal generator function. We have our get candles function to provide us our candles from the market. Then we have a trading job. It's going to get the candles, check the signal, and see if we are going to pass any buying or selling positions, provided that we are fixing our stop loss and take profit values. Now we have to execute all of this. We have to call these functions at once. We're going only to call actually the trading job function because this function calls the other functions. So in order to test if my function is working, I'm going to override the signal value. So inside of trading job function, at this point, I'm going to put, for example, signal equal to 1. So we have a selling signal. We can run this. And then I'm going to launch my function regardless of whether it's scheduled or not, just to see if it's able to connect to my account and pass any trades on the market. So this one didn't work because apparently we have a stop loss problem. If the stop loss is not wide enough, sometimes the order is canceled automatically by the API. And instead we can extend the stop loss by choosing the high minus the close minus the low value instead of the opening and closing prices. And I changed my signal to 2. So we're going to pass a buying signal, a long position. And now if I run this function and then the trading job function, I'm going to have the details. I can't show you these because I will have to show you my token and the account ID, but you'll get all the details printed down below in the Jupyter notebook regarding your order. And we can also go and check how it looks like on the Oanda account. So this is my Oanda account, and this is the buying position with just the long position we just executed automatically from Python. So this is the web interface of Oanda, and we can see that it's working. Our Python is correctly connected to the API, and it is able to pass any automated trades. Stop loss and take profits also are set accordingly. So one important note here is that any other platform you are using, if you're using MetaTrader on your phone, you can just check those trades on your phone, wherever you are, and this is a big advantage. You can also modify the stop loss and the take profit of the trades, and you can manage the trades, even close these trades manually, so you can interfere with your algorithm. It's not something that I would recommend, because if you have a winning strategy that you already backtested and it's working well, you don't want to interfere with the algorithm. However, sometimes if you manage manually your trades, it might increase your rewards. So we can comment this line, and then I'm going to define my scheduler, and I'm going to add job, and then we can start the scheduler. We have to care about the parameters. So this is the job we're going to be scheduling. So add job, my trading job. This is the function to be called, and I'm going to use a cron. The days of the week are going to be Monday up to Friday, hours 00 up to 23, so 24 hours a day. And I'm going to trade only on particular minutes of the hour. So after 1 minute, 16, 31, and 46. The reason is because I'm using the 15 minutes time frame for this demo. The start date doesn't really matter. It's simply better to put it at 12 so we can start at a fixed hour and these minutes are going to be correct. And the time zone, also you can change it for whatever time zone you prefer. It doesn't matter in this case because it's a cyclic scheduling. So it's going to be 24 hours a day and testing every 15 minutes on the market. So basically this is going to be downloading the last 3 candles every 15 minutes from the market, applying all of this function, checking take profit, stop loss, the signal, and executing orders accordingly.